Hello, my name is Flavius Penescu, and this is my Physics 2 Lab 1. This is the table of contents for my lab. We have introductions, computational models, lab results, discussion questions, and conclusion. The purpose of this lab is to give students a better understanding of charges, electrical forces, and electrical fields in the real world. The experiment observes the interactions of two pieces of charged tape and determines how much excess charge will be on one piece of charged tape. We will use the formulas we were taught in class to calculate the forces, electric fields, and charges that result from the experiment. Here are the fundamental physical principles. As you can tell, we have Coulomb's constant, Coulomb's law, electric field formula, and gravitational force formula. Here are the models of lab setup. As you can see, we have a top tape, tape B, and a bottom tape, tape A. The two tapes are a distance d between each other. This distance is 0.005 meters. We also have the mass of the top tape, the length of the top tape, and the width of the top tape, which we will use in later calculations. Here's a brief preview of the results. For the initial conditions, the top tape is located at distance d of 0.005 meters above the bottom tape. The system is the top tape, and the surroundings are Earth and the bottom tape. As you can see, the top point charge is being affected by the electric force and the gravitational force. Therefore, if we want to calculate the charge of tape B, we must equate the two forces, plug values in, and solve for the charge. Here's the code used in the lab. The code equates the force of gravity and the electric force to each other, which allows us to calculate the charge of the top tape. From there, we can calculate and print the electric field, the electric force, and the gravitational force of the tapes. Here is the program output for the code. We have the magnitude of electric field, the magnitude of electric force, the magnitude of gravitational force, and the charge of the top tape. The difference between the program and the real-world experiment is that the program makes assumptions, approximations, and idealizations that can be seen in the next slide. The similarities between the two are the fundamental physical principles used, such as Coulomb's law, force of gravity, and the principle of electric field. Here are the assumptions, approximations, and idealizations. I did not ignore air resistance on a moving object. I did treat a long tape as though it were a point charge, with all the charge concentrated at the center of the long tape. I did assume that each U-tape I made had about the same amount of charge, evenly distributed along the length of the tape. Here's the calculations for the charge of the tape. As you can see, I used the data for distance and mass of the top tape from earlier. In the calculations, I set the two forces equal to each other. From there, I plugged in values and found a charge for the top tape and the bottom tape that are equal to each other. This charge is 2.335 times 10 to the negative ninth coulombs. Any error in the results would most likely come from human error when performing the experiment. An example of this would be setting up the tapes at the incorrect distance from each other. Here are some other results I calculated. The magnitude of electric field can be found using the relationship between electric field and electric force. I found a value of 840428.46 newtons per coulombs. I also used the area of the tape and the area of an atom to calculate the number of atoms in the tape. This was 4 times 10 to the 17th atoms. I also used the charge of the tape and the charge of an electron to calculate the number of electrons in the tape. This is 1.459 times 10 to the 10th electrons. Here is the first discussion questions. What if electrons had a positive charge and protons had a negative charge? If this were true, then the observations we made with the tape would stay the same because both our tapes had the same charge. As with other charged objects, since both electrons and protons swapped, these equal changes will lead to no impact on the real world. Why is it important to handle the charged tapes as little as possible? Since the tape is charged, when we handle the tape, we can allow for the possibility of a transfer of electrons. More electrons will transfer the longer we hold the tape. Therefore, we must handle the charged tapes as little as possible because it allows the tapes to keep their charges. Ultimately, we discovered that by setting the top tape as the system, we can calculate the forces acting on it and equate the forces to zero. From there, we can use the equations for force of gravity and electric force to calculate the charge needed to hold the top tape in the air. Thank you.